We're looking into a topic called as projection of vectors. Again, all of these topics all are important. This is also very particularly important. So in simple words, this is nothing but casting a shadow of our vector onto a line or lines. So what exactly are we doing? It involves finding the component or the part of the vector that lies along a specific direction or axis. It need not be only along x and y axis. It can be between two lines, so on and so forth. Okay. So basically, if I happen to switch on this torch, right, it will cast a shadow. Is it not? Of this line. So this thing from here till here is your projection of the vector onto a line. This is known as component of the particular line, say vector A, along this vector, say B. Okay. So where do we use it? Why exactly are we talking about this? It's essentially for analyzing vector quantity and solving problems in mathematics and various scientific and engineering discipline. So if you guys remember from the start of the video, right, wherein we saw weight balancing two other weight which are of not the same weight. Basically, this video is what I'm talking about, right? So if you guys remember, this was half the weight of the other two weight, but even then the entire system is balanced. So how is this possible? So this we can explain with the help of projection of vectors. Actually, we pretty much use all the concept, but yeah, majorly this. Okay. So how do we do this though? End of it, we have to make use of our trigonometry. So the pre-requirement being, we need to know the length and the angle between the vector and the axis, if not the lines. Again, it need not be with the axis itself. It can be with any line. It's very important for us to understand this because, again, it's not only the axis we deal with different scenarios also. So we have a vector A. Okay, and if we want to project it onto our, in this case, x and y axis. So I give an example of x and y axis. That is, if I take the torch and put a light from the top, our length of A cos theta will give us the projection of vector A on our x-axis. Similarly, if I take a torch from our right side, in this case, it doesn't matter which side it is. End of it, we need to cast a shadow on the y-axis. So basically, that would be A sin theta. So this we know, right? AY is the opposite side, AX is the adjacent side. So A cos theta and say sin theta, and A being the hypotenuse. It's a very simple thing. So AY is the component along the x-axis, while AX is the component along the, sorry, this is y-axis, my bad. This is x-axis. So this is known as projection of A onto the x-axis, and this would be projection of A onto the y-axis. Okay. Right, guys. So this is the fundamental idea of projection. It's a very simple thing. Take a torch, go parallel to the surface or the line, whatever you need, project the light onto your line. Okay. So we will cast a shadow, and that shadow is your composition of the given vector onto a particular axis, if not a line. It's mouthful. It's a simple thing. It's all about casting a shadow. That's it. Everything else is just fancy words put across, nothing else. And yeah, we'll make use of trigonometry to help us out, figure out the length of the shadow and all of that. It's a very simple thing. So yeah, I have a small program. So herein I have a line, and I can change the angle and the length, and you can see how the shadow length changes. So it's just a visualization of what we just learned. Okay, so that's our shadow. Yeah, you can copy, you should be copying this as well. all of this, the terminologies are going to be useful.